Good morning, students. We'll start with the today's lecture. In the previous lecture, we have seen how to find out the stability of the system by making use of the Routh stability criteria, right? So what we have done there, just we have formed the Routh array or Routh table. After forming the Routh array or Routh table, then we have observed the first column elements of the Routh array or Routh table. If there are no sign changes, then system is stable. If there are sign changes, suppose there are two sign changes, means it indicates that there are two roots lying in the right of the S plane. If any of the roots are lying in the right of the S plane, then system is unstable, right? So that procedure we know, and we have solved few numericals based on the Routh stability criteria. The next, also there were some difficulties or special cases in the formulation of the Routh array or Routh table. We call them as difficulty 1 and difficulty 2, right? And difficulty 1, yesterday we have seen, suppose one of the element in the first column of the Routh array is 0. Only one of the element in any row, you take any row, first row or second row or third row, whatever it is, only one element, that too in the first column, right? One element in the first column of the Routh array is 0 and other elements should be there, right? Okay. And we'll solve few numericals and how to address such problems. Difficulty 1. Okay, if difficulty 1, how to overcome? Replace that 0 by small positive number, that is epsilon, which is tending towards 0, and proceed, right? Another way is replace s by 1 by z. That is another way. We'll see both the ways of solving the numericals. Then next, application of Routh stability criteria to linear feedback system and relative stability. We'll see it if time permits, right? Okay. We'll take up this numerical. By means of Routh criteria, determine the stability of the systems represented by the following characteristic equation. For systems found to be unstable, determine the number of roots of the characteristic equation in the right half of the S plane. So we will solve one by one. So I will take up part A. S power 4 plus 2s cube plus 10s square plus 20s plus 5 equal to 0. This is the given characteristic equation. Just observe all the powers of S are present. S power 4, 3, 2, 1, 0. Yes, all the powers of S are present. Observe the coefficients, all are positive. So necessary condition is satisfied in this case, right? So necessary condition satisfied. System may be stable. System may be, sorry. System may be stable. But we have to go for proving the sufficient condition, right? Okay. So we will list out S power 4. We will form the Routh array or Routh table. S cube, S square, S power 1, S power 0. Right. So we will 4, 3, 2, 1, 0. We will fill up the first column by odd term elements. Odd term means 1, 10, 5. 1, 10, 5. Next, even term coefficients in the second row, 2, 20. 2, 20. Constant is 5. So just we'll make a mark of it, right? Okay, we'll try to calculate this element. So 2 into 10, 10 to is 20, 20 minus 20, right? 20 into 20. So it will get 0 here, right? 10 to is 20 minus 20 into 1, right? 20 minus 20 is 0, right? So we are getting 0 here. Then what about this element? Just this is 5 will be getting, because you know this is reversal, right? Leave this row and 5 we will get. So this is constant term. But observe difficulty 1 has arisen. So we have to identify difficulty 1 had come. Difficulty 1, because one of the elements in the first column, one of the element in first column of the Routh array, the Routh table or Routh array is 0, right? So difficulty 1 had come. So in order to solve this, there are two methods. Replace this 0 by small value epsilon and proceed. This is one way. So we will see. Next we will see the two methods also, right? So I'll form the Routh array once again. Or else I can use the same table only, but let me take it. I'll this another table, right? S power 4 so 1, 10, 5 Then next 220. Yes, we know that we are getting 0. Replace this 0 by small value epsilon. This 5 as it is. I will replace this 0 by the small value epsilon, which is right. So, and 5, epsilon and 5. So, I will replace it here, epsilon and 5. So, this is constant, right? Okay. So, epsilon is a small positive number. It is a small positive number. And epsilon is almost tending towards 0, right? Okay, then we'll proceed with the next. We'll try to find out what is this element. So 3 elements, 2 elements, 2 elements, only one element I will be getting here. So how to calculate that? 20 into epsilon, 20 epsilon minus 5 into 2, 10 divided by epsilon, right? Only one element. Next one element no need to calculate, this constant term will be coming here. Is it fine? Constant term. Okay, observe this element. All the elements, if the system has to be stable, means all the elements in the this column should be. But we know that difficulty 1 as our system cannot be stable. Difficulty 1 had come. Difficulty 1. So system cannot be stable at all. It is either unstable or marginally stable. Unstable or marginally stable. Whenever difficulty 1 comes, it is all the time it is unstable only, right? Okay, we'll check it. If it is unstable, means now there should be number of sign change, means some of the roots should be lying in the right half of the S plane, right? Okay, we'll see it, but it cannot be stable. So just we know that, yes, just observe the first column elements of the root array. I'll change the ink color. Observe the first column elements of the root array. So this is positive, this is positive. Epsilon, it is a small positive number I told. So this is also positive. What about this? So we will see here 20 epsilon minus 10 by epsilon. So we'll separate it out. Sorry, 20. So 20 epsilon by epsilon. So just separate it. 20 epsilon by epsilon minus 10 by epsilon. So epsilon will get cancelled. So I will be getting 20 minus 10 by epsilon. And we have assumed that epsilon is a small positive number and epsilon tends towards 0. We will substitute epsilon tending towards 0. So 20 minus epsilon will substitute it as 0. So anything divided by 0 is infinity. So 20 minus infinity. So I will be getting minus infinity. So this is negative value. What I am getting is negative value. This is negative. Because minus, I am worried about the sign, not about its value, right? So minus infinity means, so this is negative. So this is positive. So how many sign changes are there? Observe here. So this is positive number, this is positive number, this is positive number, but this is negative number, this is positive. So from here to here, plus to minus, one sign change is there, minus to plus, one sign. So number of sign changes is 2. Number of sign changes equal to 2. So 2 roots lie in the right half of the S plane. 2 roots lie in the right half of the S plane. Right half of S plane. So given system is unstable. This is one method. This is first method. What we have seen is first method we have seen. So we will solve the same numerical by second method, right? Second method. I hope you understood the first method, right? You can use any one method, right, to solve this numerical. So let me take this example. S power 4 plus 2s cube plus 10s square plus 20s plus 5 equal to 0. So let me check it. Right, s power 4 plus 2s cube plus 10s square plus 20s plus 5. So we will solve by second method. Okay, we came to know that it is difficulty 1 already. Here you can see here, yes, we have formed this much. We know difficulty 1 had come, so we will go for, so difficulty 1 had come, difficulty 1. So we'll replace s by, replace, this is second method I am telling, replace s by 1 by z. Why we are taking 1 by z means, you can observe here, if I want to calculate the next element, so this divided by 0 it will come, so it will be infinite. So we have to reverse it. Instead of s, It is inverse s, means replace s by 1 by z. So modified characteristic equation. So that will avoid that infinity value, anything divided by 0. So we are taking replace s by 1 by z. So this is call this as equation 1. Replace s by 1 by z in equation 1. 1 by z whole to the power of 4 plus 2 1 by z whole cube plus 10 into 1 by z whole square plus 20 into 1 by z plus 5 equal to 0. So multiply throughout by z to the power of 4. So multiply throughout by z to the power of 4. So multiply throughout by z to the power of 4. So multiply. So I'll be getting 1 here. Z to the power of 4 z cube, right? 2z plus 10 z square, right? Plus 20 z cube plus 5 z to the power of 4 equal to 0. Rearrange it and write it. 5z high from starting from highest power of z, 5z to the power of 4, come reverse like this, right? 5z to the power of 4 plus 20z cube plus 10z square plus 2z plus 1 equal to 0. So this is the modified characteristic equation. Modified characteristic equation. Now form the Routh table for this, right? So all the powers of z are present. Z power 4, z cube, z square, z to the right, and all the coefficients are positive here. System may be stable, right? I will not say it is stable, right? So z to the power of 4, z cube, z square, z to the power of 1, z to the power. Form the Routh array, right? So in the first column, odd term coefficients 5, 10 and 1. 5, 10 and 1. 1 is constant. So mark it. This is 1 is constant. So even term coefficients 20, 2. 20 and 2. Right. So next calculate the next element 20 and 2 over next. 20 into 10. Let me calculate using the calculator directly I will do. So observe here 20 into 10. So open bracket 20 into 10 minus open bracket 5 into 2 minus 5 into 2. 5 to 10, right? So I subtract divided by this 20 divided by 20. So I'm getting 9.5 here. Right? 3 elements, 2 elements, next 2 elements, 1 this element. So this will be coming 1 only, right? Because we know this reverse cell shape. Constant over. Next calculate this element, only 1 element, 9.5 into 2. 9.5. One, let me check it. Yes. 9.5 into 2. Open bracket 1 minute 9.5 into 2 minus 20 into 1, that is 20, divided by 9.5. So I am getting minus 0.105. Minus sign is important for us. The next, this is 1 only, constant term, right? So diagonal you can check it like this. Is it fine? Okay. The next, observe the first column elements of the Routh array. So I'll change the ink color. Observe the. So how many sign changes are there? Plus to plus. This is positive now. Positive. Plus to plus. Plus to minus, one sign change. Then minus to plus, one more sign change. So number of sign changes is 2. Number of sign changes is equal to 2. So 2 roots lie in the right half of the S plane. 2 roots lie in the right half of S plane. So given system is unstable. So which method do you feel comfortable, whether method 1 or method 2? This is second method what I told. Which one is better for you? You go for that. Which one you feel better? Can you respond? Which one you feel better? Method 1 or method 2? Method 1, yes.
Method 2.
Method 2. Whichever is, okay, no problem. Whichever is convenient, you go for that. In method 1, you have to take care. Means 20 epsilon, we have to, but this value is positive or negative. Deciding this positive or negative, that is very important here, right? If we fail to identify here, then method 2 is better because we never fail. It will be always right. It is left to you. Okay. I will solve one more problem. Let me take a part A is over. Next, I will take a part B. Part C is homework. You do it. Part C is homework for you people. This one you take it as homework. Part B I will be doing it now, right? So part B, s power 6 plus 2s power 5 plus s to the power of 4 plus 2s cube plus 3s square plus 4s plus 5 equal to 0. Observe all the powers of s are present 6, 5, 4, 3, 2, 1, 0 s, and all the coefficients are positive. So necessary condition satisfies. Necessary condition satisfied. System may be stable. So form the Routh array. S power 6, s power 5, 4, 3, 2, 1, 0. So in the first column, odd term coefficients 1, 1, 1, 1. Let me check it whether I've taken question correct or not. Yes, it's correct. So 1, 1, next 3, 5. So since 5 is constant term, so let me mark it here like this for constant term. Then in the second row, even term coefficients 2, 2, 2, 2. This is over 2, 2. Next 4. Next we'll try to calculate this. Observe here 2 1 are 2 minus 2 1 are 2, 0. I'll be getting 0 here. So difficulty 1 will come here, right? So difficulty 1 had come. Difficulty. Okay, calculate other elements and tell whether it is difficulty 1 or 2, because you have to calculate other elements also. They're not just by direct this, right? Okay, it had come 0. 2 1 are 2 minus 2 1 are 2. It is 0. 0 by 2 is 0. Next, calculate this element. Okay, we'll calculate 4 elements. 3 elements means here also 3 elements I will be getting. So this 5 will come here, constant term. This diagonal, right? So we'll calculate this element. 2 3 is 6, right? 2 3 is 6. 6 minus 4. 4 1 is 4. 6 minus 4 is 2. 2 by 2 is 1. So I am getting. Directly I am doing. Observe here. 2 into 3. 6 minus 4 into 1. Right? 6 minus 4 is 2. 2 divided by 2. It is 1. So difficulty 1, because only one element. Other elements are there. 1 and 5. They are not 0. Right? So the first element in the first column of the Routh array in s power 4 row is 0. So difficulty 1 had come. Difficulty 1 or special case 1 also some people call it as, right? So replace this 0 by small value epsilon. So let me change the ink color. So I am doing by first method. You can go by second method also, right? So replace this 0 value. I am replacing here by the small value epsilon. I am replacing by epsilon. Next I will calculate 2 into epsilon. 2 epsilon minus 2 divided by epsilon. See, observe here, 2 into epsilon minus 2 divided by epsilon. Next I want to calculate this element, right? Okay, 4 into epsilon into 4 minus 5 to the 10 divided by epsilon. Next 3 elements, next only 2 elements, right? 2 elements. Next only one element will be coming here. Sorry, 3 elements, 2 elements, here 2 elements once again. So this 5 you can see here by diagonal, right? So constant term. First I'll write this, because leave this row and write this. Calculate this. So 2 epsilon minus 2 into epsilon into 1 minus this divided by this. So we'll do this. So let me, so if this multiplication is complex, but I have to do very carefully. So let me write it here. 2 epsilon minus 2 by epsilon into 1. This into 1 minus epsilon into this, right? Minus 4 epsilon square minus 10 epsilon. So epsilon will get cancelled anyhow. Let it be. Okay, fine. Let me rewrite it. 4 epsilon into 4 epsilon minus 10 divided by epsilon into 4 epsilon minus 10 divided by epsilon whole divided by this quantity, right? So 2 epsilon minus 2 by epsilon. I hope you are getting. So 2 epsilon minus 2 into this into 1 minus epsilon into this divided by this, right? Right? Is it fine? Okay, epsilon will get cancelled. So take epsilon in the denominator. This had cancelled. Okay, 1 minute. I will not cancel because we'll take LCM and we'll try to simplify it. Don't cancel it. Keep it as it is. So let me take epsilon. In the denominator it will get cancelled. So in the numerator what I will be getting, 2 epsilon minus 2 minus 4 epsilon square, minus into minus plus 10 epsilon divided by 2 epsilon minus 2 I will be getting. Let me check it whether I have done correct or not. Minus 4 epsilon square minus into minus plus 10 epsilon, sorry. Okay, let me rewrite it. Minus 4 epsilon square and 10 epsilon plus 2 epsilon, that is 12 epsilon. This is over, then minus 2 divided by 2 epsilon minus 2. So I will be getting this here. So let me write it here. Minus 4 epsilon square plus 12 epsilon minus 2 divided by 2 epsilon minus 2. Okay, this I got it. So two elements, only one element I will be getting here. So I have to calculate this into this minus this into this divided by this. Very tedious, right? So it would be better to go for second method. But let me, anyhow I have continued, so I will continue with this only. So constant term will be coming here. So one element this I have to calculate. So let me calculate. Let me use this part here. This into this, right? Okay, let me change the ink color. So this into this minus this into this divided by this, right? Okay. Let me go to the next slide only. Minus 4 epsilon square plus 12 epsilon minus 2 divided by 2 epsilon minus 2 into 4 epsilon minus 10 by epsilon 4 epsilon minus 10 4 epsilon minus 10 by epsilon minus 5 into this minus 5 into 2 epsilon minus 2 divided by epsilon. Entire thing divided by this quantity, minus 4 epsilon square plus 12 epsilon minus 2 divided by 2 epsilon minus 2. So in this case it would have better, I would have gone for second method, but let it be, no problem, right? Okay, but we should be very careful while calculating, right? Or else there is a more chance that we will go wrong, right? So be careful, right? Okay, this is fine, this is also fine. Next we'll calculate this very big element, right? Okay, here epsilon will get cancelled here, epsilon here. Okay, fine, no problem. So okay, this is very big element, so let me call this as, 1 minute. Okay, let me try to rewrite this before calculating. So epsilon, this if I substitute 0, okay, fine. If I substitute 0, this will be infinite. So let me calculate and substitute here. Okay, let me rewrite it. I will tell you why I am rewriting. I will tell you. Divided by 2 epsilon minus 2 into 4 epsilon by epsilon. So epsilon will get cancelled. 4 minus 10 by epsilon minus, same thing I will write here, 5 into 2 epsilon by epsilon, 2 epsilon will get cancelled, minus 2 by epsilon divided by minus 4 epsilon square plus 12 epsilon minus 2 divided by 2 epsilon minus 2. Let me call this as a1. This entire thing is a1, right? So I will write it here, it is a1. Okay, let me observe the first column elements of the Routh array, Routh table. All the elements, let me observe the sign changes. 1 is positive, 2 is positive, epsilon is a small positive number, right? So epsilon is a small positive number, and it is tending towards 0. So epsilon, this is also positive. Let me check whether this is positive or not. So 2 epsilon, this one, right? 2 epsilon minus 2 by epsilon. Here let me rewrite it. 2 epsilon, epsilon will get cancelled, minus 2 by epsilon. Substitute epsilon equal to 0 here, right? So 2 minus 2 by 0. Anything divided by 0 is infinity. 2 minus infinity means minus infinity I am getting. So this one I am getting minus infinity. Observe, this sign is negative here, right? Let me check for this one, what I will be getting. So minus 4 epsilon square, here it is there, minus 4 epsilon square plus 12 epsilon minus 2. So let me substitute epsilon as 0. This is 0, this is 0, minus 2 divided by, this is 0. So I am getting minus 2. Minus 2 by minus 2 means, so it is 1. I am getting 1 here. This thing is 1. This one I am getting 1. I hope you are getting what I am doing. Substitute epsilon tending towards 0. Substitute epsilon equal to 0. This is 0. This is 0. I am left out with minus 2 in the numerator. This is 0. So I am left out with minus 2. So minus minus get cancelled. So 1. So this entire A1. Let me check for this big one. Yes. Let me substitute 0 here. 0, 0. So what I will be getting, minus 2, minus 2. Minus 2 by minus 2. This one. This is 0, right? So minus 2 by minus 2 into 4 minus anything divided by 0 is infinity. So minus infinity, right? So minus 5 into 2 minus anything divided by 0 is infinity. This is 0, this is 0. So minus 2 by minus 2 I will be getting. So let me 4 minus in anything we subtract minus infinity, I will be getting minus infinity only, right? So minus infinity. Let me multiply here. So here 2 minus minus infinity, minus into minus plus infinity I will be getting divided by. So I will be getting 2 1 here. So observe here, from this I am getting minus infinity, right? 2 1 ja 2 1 ja minus infinity. From this I am getting, so sign is very important here, right? So 2 minus infinity, minus infinity, minus into minus plus, so plus infinity. So I will be finally I will be getting 0 here, right? Is it correct? I am getting 0. 0 is a with a small positive number or negative number, right? What is it? Whether let me check, cross verify I have done anything wrong here. Plus infinity, minus infinity, and this is plus infinity, right? So I'm getting 0. Let me treat it as positive number. So 5. Observe here the number of sign changes in the first column of the Routh array. Let me change the ink color. So 1 to 2, there is no sign change. 2 to epsilon, there is no sign change. Yes, there is a sign change here because plus to minus infinity. So one sign change is there. So one sign change. From minus to, this is 1 I am getting. So minus to plus. So one sign change here, one more. Then there is no sign change because it is positive here. So number of sign changes. So no sign change here, no sign change here. So two sign changes. Number of sign changes is 2. Number of sign changes equal to 2. So two roots lie in the right half of the S plane. Two roots lie in right half of S plane. So given system is unstable. So it is better to go for second method, right? So two sign changes. So two sign changes unstable. So let me do with the second method, or you will be doing it. Shall I skip it? Shall I skip it or do it?
Do it, sir.
Yes, okay, I will be doing. No problem. I will be doing it. We'll be doing with the same problem with second method. S power 6 plus 2s power 5 plus s to the power of 4 plus 2s cube plus 3s square plus 4s plus 5 equal to 0. So this is the second one, right? Yes. So I am getting, we know the difficulty 1 will come, right? So it is better to go by second method. Okay, s power 6, s power 5, sorry, we know that already. This we know how to construct root or root table. So 0 1 5, so we came to know that difficulty 1 till here you have to do, till here you do it, later on will not substitute, till here we have done it, right? So we have identified difficulty 1 had come, so replace s by 1 by z. So replace difficulty 1 had come, we should identify first difficulty 1 had come, so root test fails, so replace s by 1 by z. So 1 by z whole to the power of 6 plus 2 into 1 by z whole to the power of 5 plus 1 by z whole to the power of 4 plus 2 into 1 by z whole cube plus 3 into 1 by z whole square plus 4 into 1 by z plus 5 equal to 0. So multiply throughout by z to the power of 6, multiply throughout by z to the power of 6, multiply throughout by z to the power of 6. So I will be multiplying like this, starting from I will go like this, 5 into z power 6, because I will be getting in the order. So I'll 5 into z power 6, I will start from last term, 5 into z power 6 plus z to the power of 6 means 4 into z, 4z to the power of 5. The next 3 z to the power of 4. The next 3 is 2z cube plus z square. This one, next multiply 2z plus 2z. I am coming in the reverse way, right? 2z plus 1, z to the power of 6, it is 1 equal to 0. So this is the modified characteristic equation. Modified characteristic equation. Okay, let me construct the Routh array, Routh table for this. Observe all the powers of z are present, 6 5 4 3 2 1 0, yes, and all are positive here. Z power 6, z power 5, z power 4, z to the power of 3, z square, z to the power of 1, z to the power of 0. Okay, first fill up odd term coefficients, 5 3 1 1, 5 3 1 1, 5 3 1 1 coefficients, right? This is constant term, so mark for this constant term. The next even term coefficients, 4 2 2, 4 2 2. Let me check once again. 4 2 2, yes, fine. 4 elements, 3 elements, next 3 elements will be coming here. So this is constant term, it will be taken here and it will come here. So already I calculated, so let me calculate these 2 elements. 4 3 is 12, 12 minus, let me calculate directly here, 4 into 3 12 minus 5 into 2 10. So 2 divided by 4, 2 divided by 4, so I am getting 0.5 here. Next we will calculate this element, 4 into 1 4 minus 4 into 1 is 4 minus 5 into 2 10, 4 minus 10 divided by 4, so minus 1.5 I am getting. 3 elements, the next 2 elements, right? Okay, this is just multiply here, put tick mark. So we will calculate this element here, 0.5 into 2 open bracket, 0.5 into 2 minus open bracket 4 into minus 1.5, minus 1.5, so 7 I am getting, divided by 0.5, divided by this 0.5, so I am getting 14 here. So next I will calculate this element, right? So leave this above row, 0.5 into 2, so 0.5 into 2 minus open bracket, so 0.5 into 2 is over, minus 4 into 1, 4 on the 4 minus 4, so I am getting minus 3 divided by 0.5, divided by 0.5, so I am getting minus 6 here. So observe here, 4 elements, next 3 elements, 3 elements, only 2 elements. Don't try to calculate this one also. Once again 2 elements, once again 2 elements. So this is constant term will be taken here. So this right diagonal it is coming like this. Is it fine? So next calculate this element. Open bracket 14 into minus 1.5, 14 into minus 1.5 minus of open bracket 0.5 into minus 6, 0.5 into minus 6. So I am getting minus 18 divided by 14, divided by 14. So I am getting minus 1.28. Okay, 2 elements, next only one element I will be getting. So calculate that. So minus 1.28 into minus 6, open bracket, minus 1.28 into minus 6, open bracket, sorry, minus 1.28 into minus 6 minus of open bracket 14 into 1, 14. So minus 6.32 I got, divided by minus 1.28, divided by minus 1.28. So I am getting 4.937. And last element no need to calculate. This is my L shape, right? So diagonal. Observe next. Yes, we have formed the Routh array or Routh table. Observe the first column elements of the Routh array. So here plus 5 to plus 4 no sign change, no sign change here. 0.5 plus no sign change, plus to minus, yes there is one sign change here, plus to minus. From minus to plus one more sign change is there. From here to here no sign. So number of sign changes is 2. Number of sign changes is equal to 2. So 2 roots lie in the right half of the S plane. 2 roots lie in the right half of S plane. So given system is unstable because 2 roots are lying in the right half of S plane. I hope you understood this, right? Okay. Difficulty 1 we came to know. Next we will go for difficulty 2. If any doubts, you can unmute yourself and talk to me so that I can clarify your doubts immediately, right? Okay. Not asking any doubts. Okay, fine, no problem. Next we'll see the difficulty 2, special case, right? Another difficulty. Here all the elements in any one row of the Routh array are 0. All the elements in any one of the Routh array are 0 means, okay, I don't have a blank slide here. Okay, let it be. Okay, let me take here only this. Let me assume that this is the Routh array. This is S power something is there. Let me not worry. 4 3 2 first row, second row let me take 2 1 3 something like this. Then next, okay, 1. Okay, next 3 elements 0 0 0. Yes, observe in one row, yes this is fine, this is second row is fine, but observe the third row, all the elements are 0 here. All the elements are 0 in particular row. It may be in third row or fourth row, whatever it is. So all the elements in any one row of the Routh array is 0. Then also Routh test fails. So if the Routh test fails means, then we have to think of how to solve this, address this problem, right? So all this theory I will not tell you. Just I will solve one problem so that you will understand, right? So what to do, how to do, I'll tell you the numerical. So this is difficulty 2 because if all the elements in any particular row are 0, not only one element. In difficulty 1 means only one element was 0, other elements were there, right? For example 0 1 5, for example, other elements were there, but here in difficulty 2 all the elements in any particular row will be 0. So this is difficulty 2. And one of the thing, whenever difficulty 2 comes means it is an indication. If difficulty 2 comes means it is an indication of presence of pair of symmetrically located roots. Presence of pair of symmetrically located roots means I will tell you. So let me change the ink color here. Yes, sigma j omega. The roots here minus 2 for example, plus 4 minus 4. They are symmetrical, right? Plus 4 minus 4. Maybe this is one case. Or the roots may be located like this. Let me change the ink color once again. Plus j2 minus j2, right? This is pair of symmetrically located roots, right? Third, let me change ink color once again. Let me take purple. Okay, for example, the roots are like this, right? minus 5 plus j2 plus 5 plus j2. So I hope you are getting minus 5 plus j2 minus 5, let me write it here, minus 5 plus j2 and plus 5 plus j2. So this is quadrature, right? These are symmetrically located roots. Means if I come across difficulty 2, it is an indication that there is a presence of pair of symmetrically located roots. But system cannot be stable at all. It can be either marginally stable or unstable. Unstable or marginally unstable or marginally stable. Please keep in the mind, whenever difficulty 1 or difficulty 2 comes, means the system cannot be stable at all. It is either unstable or marginally stable. Please keep in the mind, right? So difficulty 2 comes means system cannot be stable. It can be either unstable or marginally stable, right? And it is an indication, if the row of zeros is an indication of presence of the location of symmetrical roots, symmetrically located roots. 3 cases I have shown, 1, 2, complex conjugate, right? All this, the roots can be like this. Okay, how to overcome this difficulty? Okay, how to overcome this difficulty? Okay, if I read out this, all these things you will not understand. It is better I have to solve one numerical based on this. Formula an auxiliary polynomial by using the coefficient. Just I will read out. If you understand, well and good, or else we will be solving numerical based on this. Form an auxiliary polynomial by using the coefficients of the row just above the row of zeros in the root array. This is row of zeros because all the elements are row. This is row of zeros. Row of zeros. So just above this row of 0 means this one. Suppose let me write s power 6, s power 5, s power 4, something like this, right? Sorry, s power 5, s power 4, s cube, like, okay, s power 4. There is a reason why I have changed it. I will not tell you right now, right? Just above the row of zeros means this row, this row. So we have to form auxiliary polynomial. 2, this is s power 4, right? 2 into s power, I have to write like this, 2 into s power 4, then next plus 1 into s square, just alternative powers of s, 1 into s square plus 3 into s power 0 is 3. So this is auxiliary polynomial a of s. Let me call it as a of s. Just above the row of zeros, so form an auxiliary polynomial by using the coefficients of the row just above the row of zeros in the root array. So 2 into s power 4 plus 1 into s square plus 3 into s, alternate powers of s power 4, s square, s to the power of 0, right? So this is auxiliary polynomial. Next, this polynomial gives the number and location of the roots of the character which are symmetrically located. Just now I told we will be getting, if there is row of zeros means we will be getting the symmetrically located roots. If I solve the roots of this auxiliary polynomial, it will give me the pair of symmetrically located roots. That's the meaning. The order of the auxiliary polynomial is always even. Yes, it cannot be always, it should be even. S to the power of 4, s to the power of 6, s square. It cannot be odd. S power 1, s cube, s power 5, it cannot be like that. So it is always even power of s. Please, that is also cross check whether we are getting right or not, right? Then roots of the auxiliary equation also satisfy the original equation. Yes, if I solve this 2s power 4, 4 roots I will be getting, but original characteristic equation may be 5th order or 6th order or 7th order. So not only these 4 roots, other 3 roots will be there if it is 7th order or something like that, right? Okay. Okay, how to do it I will tell you one by one. So I will not worry, all these things you go through later on, you come and read it once again because I will solve it there and I will tell you here. So one thing, in fact, whenever difficulty 1 or difficulty 2 arises, it can be immediately concluded that system is unstable. Please keep in the mind. But it unstable or marginally stable. Another thing, not only unstable, it may be marginally stable also, or marginally stable. And root stability criterion, it is an algebraic method to determine the stability of linear control system. Okay, we'll not go through this, just to go through it. So just I'll take up only one numerical and I will explain you. This time is there, I can go through this quickly. So first, let me take this part A, s power 6 plus 3 s power 5 plus 5 s power 4 plus 9s cube plus 8s square plus 6s plus 4 equal to 0. Observe this equation, all the powers of s are present or not? S power 6, 5, 4, 3, 2, 1, 0. Yes, all the powers and all are positive here. Necessary condition is satisfied. necessary condition is satisfied, system may be stable. Okay, let me read out the question. By means of Routh criteria, determine the stability of the system represented by the following characteristic equation. For the systems found to be unstable, determine the number of roots of the characteristic equation in the right half of the S-plane. Right? The same thing, previous what we have done. Okay, s power 6, s power 5. Let me go to the next slide only. That would be better. S power 6, s power 5, s power 4, s power 3, s square, s to the power of 1, s to the power of 0. Right, write down the odd term coefficients 1, 5, 8, 4. 1, 5, 8, 4. 1, 5, 8, 4. Let me check it. 1, 5, 8, 4. Next, even term coefficients 3, 9, 3, 9, 6. 3, 9, 6. 3, 9, 6. Which is constant? 4 is constant. So let me mark it like this. This is constant, right? Okay, 4 elements are there. Next three elements will be coming. This 4 will come here. This 4, right? We will calculate these two elements. 3 into 5, 15. Let me calculate. 15 minus 9 ones are 9. 15 minus 9, 6 divided by 3. So I am getting 2 here. Let me calculate this element, second element in the third row. So leave this column. 3 into 8, 8 3 are 24. 24 minus 1 into 6, 6 divided by this 3 only, divided by 3. So I am getting 6 here. So 3 elements, 3 elements. Next I will be getting 2 elements. So let me calculate this. 2 into 9, 18 minus 6 to 6 is 18. 18 minus 18 is 0. So I am getting 0 here. Next we will calculate this element. So leave this column. 6 2 is 12. 12 minus 3 into 4. 12 minus 12 0. So I am getting this also as 0. Right? 3 elements, 3 elements. Next 2 elements. So this is difficulty 2 because all the elements. This is row of zeros. Because all the elements in any S cube row are 0. So this is row of zeros. Row of zeros. So difficulty 2 had come. So I hope you were in a position to identify difficulty 1 and difficulty 2. Difficulty 1 means only one of the element will be 0 in the first column. Other elements will be there present. But here all the elements in any particular row will be 0. So row of zeros will be coming. Difficulty 2 had come. Difficulty 2, right? Then there is row of zeros. So what is this row of zeros means? It is indication of what? You should be knowing this also. Indication of presence of pair of symmetrically located roots. Pair of symmetrically located roots. Symmetrically located roots. Then system can be either marginally stable or unstable. It cannot be stable at all. It is marginally stable either or unstable. And it will see this, right? Okay, fine. Okay, how to solve this? How to overcome this? Just above the row of zeros, form the auxiliary polynomial. Form auxiliary polynomial for auxiliary spelling AUXILI ARY. Form auxiliary polynomial by using row just above row of zeros. Just above row of zeros. Form auxiliary polynomial by using row just above row of zeros. So A of S is equal. This is row of just above this row of 0 means 2 6 4. So 2 into this. I'll start with this S power 4. This row 2 into S power 4 plus 6 into alternate powers of S. To S power 4 means S square will come, right? S, leave that S cube, right? So alternate powers of into this 2, 6, 4 coefficients. Make use of the coefficients. 4 into s power 0. I will not write s power 0. It is s power 0 is 1. So this is auxiliary polynomial, right? So form an auxiliary polynomial by using the row just above row of zeros. We have formed auxiliary polynomial. We have called it as a of s. This is auxiliary polynomial, right? Simply I will write auxiliary polynomial, POLY. I will call it like this, right? Then next, how to fill up? I want to avoid this row of zeros and fill something here. So take derivative of this auxiliary polynomial. Take derivative of, I have not told you the steps. I am doing through this problem and telling you the steps directly. Take derivative of auxiliary polynomial, a of s. So derivative means a dash of s is equal to, so 4 to the 8 s cube, nx to the power of n minus, right? 6 to the 12, 12s. So this will be 0. So I am getting 8 and 12. So these coefficients of this derivative equation, 8 and 12 are the coefficients. So 8 and 12 are the coefficients of which row? That is row of zeros. That is s cube row here. Coefficients of s cube row. Then make use of this 8. Instead of 0, 0, write 8 here and 12 here. So we will continue. In the next slide I will continue. Once again you form the table. Don't rewrite here only. S power 6, s power 5, s power 4, s power 3, s square, s power 1, s power 0. So 1, 5, 8, 4, 1, 5, 8, 4. The 4 is constant term, mark it. Then 3, 9, 6, 3, 9, 6. Next 2, 6, 4, 2, 6, 4. Next row of zeros. So what are the coefficients? So auxiliary polynomial, take derivative of auxiliary polynomial, and the coefficients of this derived equation will be the coefficients of that row of zeros, that is s cube row here. So 8 and 12. So I will write it 8 and 12 here instead of row of zeros, right? I hope you are getting. So instead of zeros I am writing 8 and 12 because these are the coefficients, 8 and 12. This one 8 and 12. Is it fine? Okay, next. For 3 elements, the next 2 elements will be coming. This 4 will come as it is here. Calculate this. 8 6 of 48 minus 12 to the 24 divided by 8. So I am getting 3 here. Okay, 2 elements. So next only one element will be coming here. So 12 3 is 36 minus 8 4 is 32. So divided by 3. So I am getting 1.33. So this is constant element 4. So observe diagonally, right? So next, observe the elements of the first column of the Routh array. So observe here, all are positive here. If all are positive, doesn't mean that system is stable, because difficulty 2 had come. Whether difficulty 1 or difficulty, system cannot be stable at all. Just by looking at this, all the elements in the first column of the Routh array are positive, so given system is stable. Don't say like that, because difficulty had come here. Difficulty 2 had come here. Difficulty 2 means either system cannot be stable at all. In any case, it may be either unstable or marginally stable. Unstable or marginally stable. Marginally stable. Don't go by this by looking at the roots of the first column elements of the Routh array, right? Because it can be either unstable or marginally stable. So we have the character auxiliary polynomial a of s, auxiliary polynomial. Find out the roots of auxiliary polynomial. That will give me the pair of symmetrically located roots. So 2s power 4 plus 6s square plus 4 equal to 0. So find out the roots of this. So put x equal to s square. I'll do this. 2x square, right? I hope it's correct. 6x plus 4 equal to 0. So put x equal to s square. So I'll be using the calculator equation, which how many second degree. So coefficient is 2, b is 6, c is 4. So calculate the roots. So minus 1 is one of the root. Next minus 2, minus 2. I think minus 2 is repeated twice. Minus 2 minus 2. Sorry, only correct. Only two roots, right? Okay. What is x? X is nothing but s square. S square equal to minus 1 and s square equal to minus 2. Two roots. So this is 1 comma 2, 3 comma 4. So first and second roots are plus or minus j, right? Root of minus 1. So plus or minus j. Here third and fourth roots are plus or minus j root 2. I hope you are getting, right? So four roots, plus or minus j is one root, plus or minus j root 2. You can observe they are symmetrically located roots, plus or minus j and plus j root 2 and minus j root 2. There we are getting, so these are symmetrical roots. So four roots we have found out, but this is sixth order equation, right? So I'll try to find out the other two roots also, because you can observe here sigma j omega plus j minus j. So plus j minus j, fine. Another set of roots plus j root 2 plus j root 2 minus j root 2. So by looking at these roots, we will come to know that system is marginally stable, but we'll try to find out other two roots also, right? So that it will give us clear picture. So how to find out the other two roots? We have this already, right? So 2s power 4 plus this auxiliary polynomial. So I will divide this with the original equation. So s power 6, right? This is the original equation, right? So and this is the one of the factor. So 2s power 4, 2s power 4 plus 6s square plus 4. Division method, s power 6, s power 6 plus 3s power 5 plus 5s power 4 plus 9s cube plus 8s square plus 6s plus 4, right? Let me verify it. 5s power 4, 9s cube. Yes, it's correct. So why I am doing this means, because four roots we came to, but this is sixth order equation. Other two roots I have to find out. So this is so divided. So s square I will take. If I take s square, is it fine? Any problem here? S square by 2 if I take, I will get s power 6, right? So s square by 2. Is it fine? So 2 will get cancelled, s power 6 I will get. So this is fine, I think. Is it fine? If I multiply, see here, 2 will get cancelled, s power 4 into s square, s power 6. This is fine. So 2 1 ja 2 3 ja, s square s power 4 I will be getting this one. But 2 1 ja 2 3 ja, 3s power 4. Next 4 into this, 2 1 ja 2 2 ja, 2s square. So 2s square I will be getting this. Subtract it, this will vanish. So 3s power 5, take it as it is. 5 minus 3, 2s power 4 plus this 9s cube as it is, plus 8 minus 2, subtract it, right? So 8 minus 2, 6. So this is minus, right? Subtracting. So we are subtracting. So 8 minus 2. So 6s square plus 6s plus 4. If any other method, you can go for that, or else you can use this method. Next, I want s power 5. So yes, if I multiply by s by 2, so 2 will get cancelled. S power 4 into s power 1 is s power 5. So I want 3, no? So this should be cancelled. So what I should do? 3 into s by 2, let me write it. Right, 2 will, so 3, yes, fine. 3 s power 4 into s power 5. This is fine. Next, 2 will, next 6 into 2 1 ja, 2 3 ja. So 3 3 ja 9, 9 s cube. So 9 s cube I am getting. Next, 4 3, 2 1 ja 2 2 ja 4, 2 3 ja 6, 6 s, 6s. I hope you are getting what I am doing, right? So this is minus, this is minus, this is minus. They will vanish. This will vanish. This will vanish. So I am getting 2s power 4 plus 6s square plus 4. So same it is. So plus 1. Multiply it, right? 2s power 4 plus 6s square plus 4. So this will be 0, right? So 0, I got it. So the factors are 2s power 4 plus 6s square plus 4 into another set of roots, s square by 2 plus 3s by 2 plus 1 equal to 0, right? So we'll solve the roots of this. So just multiply by 2, right? Multiply throughout by 2. S square plus 3s plus 2 equal to 0. I hope, right? So this already we have found out the roots. 4 roots we have found out, symmetrical roots. Only this factor I will be using. Multiply throughout by 2. So s square plus 3s plus 2 equal to 0. Is it fine? Okay, find out the roots of this. So equation 1, degree is 2. So a is 1, b is 3, c is 2. So roots are minus 1 is equal to minus 1 is one root. The next another root is minus 2. You can observe here. Yes, minus 1, minus 2. They are lying in left half of S plane. Means minus 1 is here and minus 2 is here. But observe, so these are dominant roots. So the roots of the characteristic equation, the roots of the auxiliary polynomial are the dominant roots. They get the step. So given system is marginally stable. The other two roots are minus 1, they are lying in the left of, they are not going to affect the stability, right? But these are going to affect. So we call this as the roots of the auxiliary polynomial, we call it as dominant roots. Then they are, so given system, non-repeated roots are present on the imaginary axis. So I will write one statement, non-repeated roots. Let me change the ink. Non-repeated conjugate roots on imaginary axis. Imaginary. So given system is marginally stable. If any doubts, you can unmute yourself and talk to me. Let me stop. I hope you understood difficulty 2 and how to overcome it. The same thing has been given in wordings here. Replace the rows of zeros in the root array by coefficients of polynomial generated. Wrote all these things, whatever I told. Just go through it. So I have not covered all these things because if I tell the problem as good, if you read it now, you will understand, right? Okay. Then I'll stop recording.